Okay, so let's wrap things up by doing a quick algebraic example to really drive the point home. So let's suppose that we've got demand represented by this equation, and we've got supply represented by this equation. And remember that supply we had been also equating to private marginal cost, right? But now, because of the externality, the social marginal cost is different than the private marginal cost. And we can see we've actually got the supply equation in here, but in addition, there's this externality, right? I've just chosen some really simple numbers and some simple functions to sort of represent this, but it's going to allow us to do this example pretty quickly. So in the market equilibrium model, the perfectly competitive one, demand and supply are really all there is. And so this is a system of two equations. Each equation is representing a line. And so in a system of two equations, when you're trying to find sort of the intersection point, right, it's the point at which both of these equations are true, right? So if both of these statements are true, then we can just pretty simply solve it. So since we're going to use the demand equation, but we're going to substitute in QS. I'm going to keep the subscripts for a second, but I'm going to drop them shortly. Equals 100 minus QD, right? I've just substituted this equation in here, right? And now I'm going to drop the subscripts just to show you that this gives us 2Q equals 100, and then Q, that means that Q star is 50, right? And that's just the quantity at which those points intersect, and you could plug that back in and find the price. But let's imagine that actually we think there's an externality, and so we're going to use the demand equation, but then we're going to use the social marginal cost equation, right? And if I do the same thing, I see that we get QS plus 2 equals 100 minus QD. And again, I'm going to drop the subscripts now because the quantity is going to be where both equations are true, so we can sort of forget about the differentiation of supply and demand here. And that means that we've got, what, 2Q equals 98, which means that Q star here is actually 49, right? Notice these aren't equal, right? And we wouldn't expect them to be because there's this dead weight loss, and the actual sort of optimal provision in the face of the externality is actually less, right? There's less oil that should be produced if we were actually calculating in the externality there. All right, so this is a big deal in the oil market because the oil market has this negative externality, the damaging effect that oil has on the atmosphere via greenhouse gases that leads to market failure, and that's a key part of the conceptual model that environmental economists use to clarify what the fundamental problem is in global climate change and to help it fix it.